And so starting in on the demo here, I have a couple of different data frames, Baltimore County land use, land cover, and Maryland County population. We'll get into this data frame with all of these different renditions of the same exact shapefile, just showing the different classification schemes that we talked about in the previous lecture, showing Maryland County population. But we're going to start here with Baltimore County land use, land cover. We have a basic shapefile here of the different land uses. And again, I'm just going to zoom in here and refer to the Maryland land use, land cover classification scheme that we talked about in the first video. How we have our 10 series of numbers, urban built up, and then of course our agriculture. We don't have a 30 series in Maryland, by the way, because of the lack of rangeland. They have that more in western states, so we don't use that here in Maryland. I might have mentioned that in the previous video. Forest is going to be in the 40 series of numbers, so you can see deciduous evergreen, 50 for water, 60 for wetlands, 70 is barren land, and then if a transportation corridor is big enough, it would be tagged in the 80 series. So again, that's a resource document that you guys can use so you can get an idea of what it means when I say LU code in the demo here. So if I just click on any one of these individual polygons, I can see that I have an LU code of the one that I just clicked of 11. So according to our document, that is low density residential. I'll click on this big polygon right here, and it may look familiar to some of you. That's Lock Raven Reservoir. And so we're talking about an LU code or land use code of 50, which means that it is water. So what I'm doing here is I'm just showing these polygons as single symbol. But what I can do is I can actually click to the next version of it, and I'm going to zoom back out here and show you that I am symbolizing, rather than a single symbol, this purplish sort of violet polygon, I've now chosen to show this data by land use code, but I'm only showing 11s, 12s, and 13s. Those are their low, medium, and high density residential polygons within the county of Baltimore. Now the way I've chosen to show that is I've gone through and removed the values that I don't need from the symbology tab. Now that doesn't mean that I've removed it from the data. I can actually just come back here into single symbol and apply that, and if I did that, it would go back to the full range of polygon values. So I can come back in here in the symbology tab and say that I want to show up by categories, and I'm going to go by land use code and add them all back in, and of course you'll see all of the different values for those different land use codes. But for me to just remove those and just show 11s, 12s, and 13s, and again I'll just kind of bring it back to what I had. I think I had an orange color here, so bear with me as I sort of change the symbology, and I think I did some browns here if I'm not mistaken. So I'm just using that sun value as a starting point to remove the outline, and then I'll get into my browns. I think this is pretty close to what I had before, so I'll just say that. And then you can see that all the other values are tagged as that violet color, so I'm just going to kind of take that out, and I'm back to having something closer to what I want to show. So again, the light colored yellow polygons are low density residential. As we get in around the city here, we see more medium and high density residential. High density residential, of course, being condos and apartments and those kind of land uses. Same shapefile again, symbolized a different way. I'm just going to expand that, and now I've gone through and grouped the 11s, 12s, and 13s together. So instead of breaking them out individually by their land use codes, I'm grouping them together, and anywhere where you see this light pink color is basically a use of residential areas. Once you get into the 14s, into the 18s, again, if I go back to our resource document, we can see that those are other urban built up land uses, but they're not necessarily any kind of residential areas. So I have a choice as to the story that I want to tell and how I want to present my data, and so that's some basic symbology choices that I'm making with this kind of data. So I'm going to go ahead and just minimize this. I'm going to right click on Maryland County population. I'm going to activate that, and I have nothing there because I have nothing turned on. So I'm just going to turn on Maryland counties. I'm going to zoom to the extents here and tighten it up a little bit. And again, similar to my Baltimore land use land cover for Maryland counties here, by default ArcMap is just going to say, you know what, I'm just going to show this by this sort of tealish kind of color here. I can click on any one polygon, and I can see I have lots of different data that I've used in the past for estimating populations at risk of flooding for each of these individual counties. But for the purposes of the demo here, I'm not worried about all of these other fields. I'm just going to kind of concentrate on the population 2000 field and the age 65 and up field, as you'll see down here in one of the last sections of the demo. So the population is really what we're going to be using, POP 2000. In the lecture we talked about POP 2003. This happens to be a data set that has data from the year 2000. So I'm going to go ahead and close that out. I'm going to turn off this very simple sort of rendition, if you will, of Maryland counties. I'll minimize that, and I'll turn on this rendition of Maryland counties, which is somewhat not very useful. Although, if you think about it, it is showing our lower population counties in some sort of shades of green, which kind of makes sense. Our western counties and our lower eastern shore counties are our lower populations. And then, of course, we've got our higher population counties that happen to fall within the PG, Montgomery County, Baltimore City, Baltimore County polygons. The color ramp that I've chosen here sort of does tell us some information, but that's not a very practical way to show our legend. Again, showing the POP 2000 field here. So if I went in there and I said, you know what, I'm not going to use that, I'm just going to kind of pick random colors, now the map again becomes extremely useless because each one of those colors probably repeats itself at some point, and it's hard to distinguish what we're looking at here. So this is a really good candidate for actually classifying our data, which is what we talked about in the previous lecture video. So I'm going to go ahead and turn that one off and turn that on, and I'm going to show Maryland counties based on natural breaks. And so you can see what I've done is I've taken the population 2000 field and I've broken it out into 1, 2, 3, 4, 5 classes, and so it's looking to see where the number of features that are kind of naturally grouping into each of these different categories and color coding the map accordingly. This kind of makes sense. Again, it sort of jumps out. The urban core, the Baltimore City, Baltimore County, Montgomery, Prince George's counties sort of jump out. Some of our lower population counties in the western part of the county into the eastern shore, lower eastern shore, are on the low end in terms of population. You do see that Wicomico County does come up a little bit. We do have a major university in the town of Salisbury. Population is going to be a little higher in an urban area and with a university. So that one actually jumps up into the next grouping. And of course, that's using our natural breaks classification. I mentioned in the video that you would do this within the Symbology tab, and here we're using graduated colors to show quantities. Again, these are ratio values, these are numeric values, so we're showing graduated colors for each of the polygons. Here with the range, you actually specify what the numbers are that you want your ranges to be at, and then the label here, you can actually control of how it shows it over here in the legend, and you'll get to play with that a little bit in the exercises. I also mentioned normalization. In this case, I'm not going to normalize this data. We're going to show some other normalized values over here, but you can actually take this POP 2000 value and divide it by another field within the same shapefile within the same feature class so that you can normalize your data and look at density or look at percentages. In this case, the default here was 5 classifications. We can come in here and use the classify tool, and again we can see that Jenks natural breaks is the classification method, but here's all the several of the classification methods that we talked about in the lecture previously. So you can change your break values here. You can also change your break values here as well for all of your different classes. So I'm going to cancel that, and I'm just going to go ahead and turn off natural breaks. I'm going to show the same data by quantiles, and again 5 different categories, and that creates a slightly different map. I'll turn on natural breaks here, and you can see that it sort of distributes the data differently. And so we see, for example, here Baltimore City and Baltimore County are actually 2 different categories when we talk about showing them according to natural breaks, but as part of quantile they do actually get put into the same category. So if we think about it, we've got 5 classes here. We've got 24 jurisdictions, 23 counties and Baltimore City. So right off the bat we're looking at one classification. This highest classification only has 4 features in it because we're putting the same amount of features into each one of these classes. So that's something to consider if you're ever going to use quantile classification scheme. If we look at equal interval, again telling a different story with the same data, we can see our intervals here. Equal interval means that we're going to have the same difference between the low and the high value for each of the different 5 classes that we use here. The one I didn't put in here was defined interval, where you would go in and indicate what you want that interval to be. Again, here I might want to consider doing intervals of say 50,000, since I'm looking at values up over 800,000. So maybe even 100,000s if I were to use defined interval. So again, we're telling a different story, but one of the sort of consistent stories is that we sort of focus on the urban core here. We see a lot of our other counties. We see Frederick County does pop up a little bit. We have the city of Frederick out there, a little bit higher population. But a lot of our sort of peripheral counties, in the sense of away from the urban core here in the western part of the state, the lower eastern shore, our lower population counties do wind up in one of the lower classes in terms of the classification of the data. So if I turn that off and I turn on standard deviation, another map that, again, we're not showing actual values here, we're showing how they vary from the mean. In the example in the lecture, I think there was 5 classes here, we did 4. Kind of makes sense that Baltimore City, Baltimore County, Montgomery County and PG County, Prince George's County would be well above the mean for the entire data set, whereas our lower population counties in Allegheny, Garrett County, the Eastern Shore, Lower Eastern Shore, and then parts of the Lower Western Shore are going to be our lower population counties, and they're going to be well below the mean or well below the average, again, for the entire data set. So there may be some utility in showing your data this way, but again, it depends on the story that you're trying to tell. So I'm going to go ahead and minimize this, and I'm going to show some data that has been normalized. So what I'm doing here is I'm basically looking at a density map. I'm showing this, and I'll go ahead and open up the properties here. You can see I've chosen a normalization field. We actually have a square miles field in this shapefile that tells us the square mileage of each of the different counties. And so we can see that we're taking our population in 2000 and dividing it by the square miles, and so that's giving us how many people per square mile for each of the counties. You'll notice that Baltimore City is in a class by itself, a class of its own, because it is the smallest jurisdiction, and there is also a large number of people there. So we're talking about 1,700 to 8,000 people per square mile versus some of the larger counties. Even though they're larger, they do have high populations as well, but when you consider people per square mile, they do get bumped down into a lower class, simply because of not just the number of people, but the number of people relative to the square mileage of each of those polygons. And another way to symbolize is to look at, to normalize your data is to show a percentage rather than a density, population per square mile. Here we're talking about number of people age 65 and up that represent a percentage of the total population, which is captured within the POP 2000 field. If I just open up the attribute table here, this might make a little bit more sense. As I scroll over, I'm looking at, this is the POP 2000 field. Each one of these records is a different one of the counties, and of course here is my age 65 and up population, which again represents a percentage of the total population. So we're using those two fields together to indicate what percentage the age 65 and up population represents of the total population. These numbers are a bit long, a little inscrutable, but if you think about it, 0.07 is going to be about 7% to 9%, 9% to about 11%. We can change all that. We have control over that. That's just showing it sort of raw numbers according to the way it's captured within the data set. But if I were to look at the properties for that layer, this might be the actual number itself, but in this case I could say 7% to 9%, sort of verbally stating that. And I could go through and I could do that for each one of these, but I'll just apply that. And again, not changing the data, I'm just showing it in a method that's a little more intelligible to your average map reader. So when we were to go to lay this out, say in some sort of a layout, to actually create a map, maybe I'm going to create an 8.5 by 11 map of the state of Maryland here, just really quick and dirty. And then I'm going to zoom to the extents of Maryland. If I were to insert a legend here, I'm just going to take the defaults and kind of pop through here really quick. You can see it makes more sense to see these values written out as 7 to 9% instead of these excruciatingly long numbers. So think about that as you include your legends within your map. I'm going to come back over to the data view here. This is just visually changing this information, whereas by default ArcMap is going to show them according to the actual range values that we set up here. So things to consider as you're making your maps, things to consider as you're moving on into assignment number 3. Assignment number 3 is going to require you to use the skills that you learned as part of practicing what you saw here in the demo, but also practicing items from chapters 5 and 6 in the green GTK book. So off you go into your assignment, into your exercises, and we'll be ready to move on to the next module after this.